Let's study the different characteristics of the secant function. As you can see, the graph of the secant function can be derived using the graph of the cosine function. So let's start by determining the domain of the given function. As you noticed, there is a point on the x-axis in which the function does not exist. These are the points at which the asymptotes intersect the x-axis. If you also notice, this point is also the x-intercept of the cosine function. Getting the coordinates of these, so we will have midway of -2 pi and -3 pi. That will be negative 2.5 pi or 5, -5 pi halves. Okay, then here we have -3 pi over 2. Okay, then we have here negative pi over 2. Then this will be positive pi over 2. Then here we have 3 pi over 2. Then at this point, we also have a vertical asymptote. We will have an asymptote at the point having abscissa 5 pi over 2. Now looking at this value, -5 pi over 2, -3 pi over 2, -pi over 2. On the positive side, we have pi over 2, 3 pi over 2, 5 pi over 2. We can formulate the general description of the domain of secant function. So let's start. The domain of secant x is the set of all x's such that x is not equal to these points, -5 pi over 2, -3 pi over 2, and so on. So as you notice, these are multiples of pi over 2, not just multiples. These are odd multiples of pi over 2. So we write x is not equal to n pi over 2 plus pi over 2, where n is an element of the set of integers. Or you can also say that the domain is the set of all x's such that x is not equal to n pi over 2, where n is an odd number. Now, what about the range of secant x? So as you can see, we have here downward, there is no limit. Upward, there is no limit. However, in the middle, this, the space between -1 and 1 is not included in the values of y. So that means the range would be the set of all y such that y is, for the graph that opens downward, we will have less than or equal to -1. Now for the graph that opens upward, we will have y is greater than or equal to 1. So that's the range of the secant function. Now what about the amplitude of secant function? So we remember how to get the amplitude. We determine the minimum point and the maximum point in the given function. Then we get their average. Okay, so we have a problem. We cannot determine the minimum value and the maximum value of the graph or of the function. So that means the amplitude, just like the tangent function, is not defined. To determine the period, we have to trace, just like what we did. Now let's say we start tracing from this point. So we have up, then we have here, there's another pattern, and here. Now I'll stop tracing up to this point because this other side is just the repetition of the first curve that I have traced. So we get the distance from -2 pi to 0. The result is 2 pi. So therefore, the period of secant function is 2 pi. In the interval 0 to 2 pi, the frequency is 1. Okay, so these are the different characteristics of the secant function. The equation of the secant function is given by f of x equals b plus a times secant of cx plus d, where c gives us the number of complete cycles on the interval 0 to 2 pi, while b gives us an idea of the vertical movement, whether it's shifted upward or downward, and d tells us whether the graph is shifted to the right or to the left. To find the exact number of units of shift, we have to divide d by c. A here does not give us the range of the secant function. A here describes the range of the cosine function. But since we can derive the graph of the secant function from the cosine function, A here does not give us exactly the range of the secant function, but it gives us an idea about the range of the secant function based on its corresponding cosine function. Now let us discuss the different effects of changing the variables a, b, c, and d. Let's start by changing the value of the variable a. So from secant x, this time we will have g of x equals 2 secant x. So you can see on the screen the graph of the given functions. For the green curve, we have f of x equals secant x. Now for the purple curve, we have g of x equals 2 secant x. Now let's start determining the significant change or changes in the domain, range, and period. Amplitude is not defined, even if we have changed a to 2. So we will just determine the significant changes in the mainly on the three characteristics: domain, range, and period. So in f of x, remember that our domain is the set of all x's such that x is not equal to n pi over 2 plus pi over 2, where n is an element of the set of integers. For g of x, is there a change in the domain? Notice that the vertical asymptotes did not change. Okay, we still have the x-intercept of the cosine function. Okay, so just like a while ago, we have here the intervals. Okay, so we can see that this is negative pi over 2, then we have negative 3 pi over 2, and 5 pi over 2. Then on the other side, we will also have the same pattern. So therefore, we can see that there is no significant change in the domain. Now, what about the range? Okay. The range of secant x is the set of all y such that y is less than or equal to -1, or y greater than or equal to +1. Now for the g of x, secant 2, 2 times, or now for the g of x, which is described by the function 2 times secant x, the range would be, okay, notice that we have here 2, then negative 2 for this point. So therefore, there is a significant change in the range. So the range would be the set of all y such that y is less than or equal to negative 2, or y is greater than or equal to positive 2. Okay, so that's a significant change. Amplitude is not defined. Now, what about the period? So if we start here, okay, we trace, then we trace here, then we trace here. We will not anymore trace this because this is the repetition already of the first curve that I have traced. So the period, remember the period of secant x is 2 pi. Now, as you can see, it did not change. So there is no significant change. The period is still 2 pi. Now, what about if there is a change in the value of b in this function from 0, b is 0 in f of x, while in g of x, b is positive 2. So let's see if there is a change in the domain. Now take a look. The vertical asymptote still unmoved. Okay, so it's still halfway between negative pi and 2 pi. Here we still have midway of negative pi and 0. So the same here and here, and so on and so forth. So that means for the domain, there is no significant change. What about the range of the given function? So remember that the range of f of x is the set of all y such that y is less than or equal to negative 1, or y is greater than or equal to positive 1. We still have the same interval. Okay, so let's see. We have here the purple. So take note, we have here 1. Okay, then here we have positive 3. So if we draw a line there, you can see the gap between the curves, between the set of curves. Now, therefore, there is a significant change in the range. So from the interval negative infinity to negative 1, union 1 to positive infinity, the range would be y, the set of all y, such that y is, this is positive 1, y is less than 1, or y is greater than or equal to, take a look at this point, equal to 3. Okay. Amplitude is still not defined. What about the period? Was there a change in the period? No. Okay, we still have 2 pi. So if we will trace here, so complete curve here, then we have, so from negative 2 pi to 0, the period is 2 pi. So no significant change in the period. For the frequency, we have the same. So in other words, there is only a significant change in the range. With this change, we can see that the graph was shifted 2 units above. Okay, so originally, the turning point in the function secant x is at negative 1. Well, for those graphs that opens downward. So we have negative 1, it becomes positive 1. Now in this graph, from positive 1 to positive 3, difference, we have 2 units. So in other words, the change in B will tell us whether there is a vertical shift upward or downward. Okay, so if the value is positive, then there is a movement upward, while if the value of B is negative, there is a movement downward. Okay, now what if there is a change in the value of C? So as you can see, it seems that there are a lot of curves now. So that means the domain has changed. So if in f of x, the domain is the set of all x such that x is not equal to n pi over 2 plus pi over 2, where n is an element of the set of integers, then what will be the domain of g of x? So let's determine the vertical asymptotes. Okay, remember that these are divided equally. So, then we have another asymptote here. Okay, then we have here. Okay, and so on and so forth. So let's identify or determine the points here. Okay, so as you can see, we have 0 to pi. Then there are, how many points would it be? Here we will have pi over 2. Okay, so this will be pi over 2 because it's midway between 0 to pi. Then we will have, this will be, so at this point we have pi over 2. This is pi over 6. Okay, then we will have, this is at this point we have 2 pi over 6. Then if you will express pi over 2 with a denominator of 6, then we will have 3 pi over 6. Then we will have here 4 pi over 6. And here we have 5 pi over 6. Then we have 6 pi over 6. So if we concentrate on the numbers pi over 6, then we have, here we have 3 pi, 3 pi over 6. And next we have 5 pi over 6. And the pattern continues to the right and to the left. So these set of numbers are multiples of pi over 6. So the domain of g of x is the set of all x such that x is not equal to n pi over 6 plus pi over 6, where n is an element of the set of integers. Okay, so there's a significant change in the domain when we have a change in C. Okay, what about the range? The range of f of x is the set of all y such that y is less than or equal to 1 or negative 1, or y is greater than or equal to positive 1. What about in g of x? As you can see, we have the same. So no significant change in the range. What about the period? Okay, so let's see. For f of x, the period is 2 pi. Now, in the interval from 0 to 2 pi, you can see that there will be 3 complete cycles. So let's trace. So, then we have So we have one set. Then another set, I'll use a different color. So here and here, another set. Okay, so from this point, from here, then here, and here. So we have 3. Therefore, the period would be 2 pi over 3. Okay, so 2 pi over 3, as you can see, this falls on 4 pi over 6. Okay, when we reduce lowest term, we'll give you 2/3 pi. Now, what if there is a change in the value of d? Okay, so f of x is here, the green color, then g of x is given by secant of x minus 2. So as you can see, the curve's behavior is still the same. So that means the period is still the same. However, the vertical asymptote has changed, and it's like the graph was shifted 2 units to the right. Okay, how did I say that? So let's consider this point and this point. There was a change 2 units to the right. Okay, so that's it. The different characteristics of the transformed function of secant x.